Hello everyone, welcome to Raos Academy. Today we are going to discuss jet streams, air masses and friends. Very important for prelims, not only prelims, even in your climatology mains questions also you have to use these jet streams. In Indian climate, in Indian monsoon, everywhere you are going to see these jet streams. If you take UAE rainfall, floods, extreme climates, because of weakness of this jet streams, we have seen extreme climates in current affairs we have seen. So, jet streams, air masses and friends are very important for your prelims as well as your mains. So, let us start the session. First, what happened? Now, what are jet streams? How we have discovered these jet streams? What happened during World War II? During World War II, among all chaos and tragedies, something happened. Something we have discussed during World War II regarding our atmosphere, regarding our atmospheric circulation. Now, Japan, west side, US, east side. In the middle, what you have? Pacific Ocean. What happened during World War II? American bomber jets that flew from US to Japan, from east to west, flew from USA to Japan. So, what happened to these American jets? What we have observed, what they have observed? These jet streams observed significant reduction in speed. But when they came back from Japan to USA, the speed has increased. Means when these jets, American bomber jets, traveled from east to west, speed has been decreased. But when same jets, American bomber jets, traveled from west to east, from Japan to USA, the speed has been increased. Why we have seen this speed reduction and speed increase? So, they have observed this atmospheric circulation, and after careful observation of this phenomena, they found that there was a strong air circulation in upper layer of atmosphere, and because of this strong upper air circulation, we have seen these jet streams reduction in speed, and that strong upper air circulation, they have named it as jet streams. So, now in this session we are going to see what are jet streams, and after that how do they form and types of jet streams, very important. So, now what are jet streams? What are jet streams? Jet streams, narrow bands of very strong winds blowing in the upper troposphere. At speeds of 150 to 400 km per hour, very speed, and in upper troposphere. Why speed? Because you don't have any frictional drag, because in upper layers, for example, this is at surface, what you have? Frictional force, obstructions, because of mountains, trees, everything, velocity of wind decreases on the surface, but as you go up, you don't have any obstruction, you don't have any frictional drag. Because of that, the speed of these jet streams is very fast. First thing, what you have to remember? Jet streams, very strong winds blowing in upper troposphere, that you have to remember. And main thing, direction, they flow from west to east, Westerlies in the atmosphere. See, we have surface winds also, planetary winds, westerlies. Those are different, those are permanent winds. Westerlies in the atmosphere means those are jet streams. Upper atmosphere, westerlies in the upper atmosphere, they can give confusing words. Westerlies in the upper atmosphere means jet streams, that you have to remember. Altitude around 9 to 6 kilometers above surface, that you have to remember, near the tropopause, near the tropopause. Next, here you can see. And one thing what you have to remember, in both the hemispheres they flow from west to east, west to east. Actually jet streams are geostrophic winds. Geostrophic winds. Geostrophic winds are parallel to isobars. What happens? These geostrophic, when pressure gradient force excuse me, when pressure gradient force is balanced by Coriolis force, we have geostrophic winds. What happens? For example, this is high pressure area. This is high pressure area, and this is low pressure area. Because of pressure gradient force, wind moves from high pressure to low pressure. When this pressure gradient force is balanced by Coriolis force, the wind moves in this direction. The wind moves in this direction, parallel to isobars, parallel to isobars. Those winds are known as geostrophic winds. Geostrophic winds. Jet streams are geostrophic winds, that you have to remember. Geostrophic winds in the upper atmosphere, upper troposphere. Atmosphere, upper troposphere, you have to remember, near tropopause. Now, how do jet streams form? They form due to temperature contrast, temperature difference. Strong horizontal temperature gradient between polar cold air and tropical warm air. Polar cold air and tropical warm air. Because when temperature difference is high, if you see temperature gradient, more temperature gradient means more pressure. More pressure means more strong winds. And those strong winds, because of the strong horizontal gradient force, temperature difference between polar cold air and tropical warm air, and pressure gradient force. Large temperature difference means large pressure. Because of this large pressure difference, what happens? You will see strong winds. You will see strong winds. What happened? Hadley cell. Did you remember Hadley cell? At equatorial low pressure, in upper layers, what happens? Warm air comes from this side and cold air comes from this side. Because of this temperature gradient, strong winds form here in the upper air circulation, and here they flow like this in a circular formation, upper troposphere. And here also, here warm air comes from temperate regions and here cold air comes from polar regions. So we have two jet streams in each troposphere. Two jet streams means total 4 jet streams, because of temperature difference and large pressure difference and even Coriolis force. Because of the Coriolis force, winds move parallel to isobars. Due to Earth's rotation, winds deflect and move west to east, from west to east. If I ask jet streams, because of pressure gradient force, jet streams move from west to east? No, it's a wrong statement. Because of Coriolis force, wind moves from west to east, that you have to remember. First thing, temperature difference. Because of large temperature difference, we are going to see large pressure difference. Because of large pressure difference, large pressure gradient force, we are going to see strong winds. Because of that those strong winds blow from west to east because of Coriolis force. Next, we are going to see characteristics of jet streams. First, its genesis means origin is associated with the thermal contrast of air cells. For example, Hadley cell and Ferrel cell. If you don't see any thermal contrast, you don't see any strong jet streams. Okay, if thermal contrast is strong, on this point you can interlink with climate change or global warming. For example, if cold air coming from polar regions, because of global warming, if that polar cold air is not that much strong, cool, or not that much cool, what happens? You don't see any strong temperature contrast. If strong temperature contrast is not there, what happens? You don't see strong pressure gradient force. If strong pressure gradient force is not there, you don't see strong jet streams. You will see weakening of jet streams. If weakening of jet streams happens, you will see disturbances and you will see extreme climatic conditions also. Extreme climatic conditions. Next, the meandering or the will movement of jet streams is known as Rossby waves. What happens? Jet streams follow meandering path. Why? Meandering means like this. Yes? Meandering path. Why? Because non-uniform Actually what happens, at some points cold air mass approaches warm air mass at very much faster rate, and at sometimes warm air mass, for example, now this is warm, from here cold. At some places cold air mass approaches very fast than warm air, and at some places warm air mass approaches cold air mass very fast. Because of this non-uniform interaction, you will see Rossby effect or meandering path. Because of this non-uniform interaction, we are going to see meandering path, and because of that, these waves are known as Rossby waves. Rossby waves. If I ask Rossby waves are related to jet streams or tsunami or any other thing, you have to remember Rossby waves are related to Rossby waves, where we have learned in jet streams. That you have to remember, because of non-uniform interaction between warm air mass and cold air mass. Clear? Next, equatorial extension of jet stream is more in winter because of the southern shift of pressure belts. Why we will see southern shift? Because of the apparent movement of sun, the thermal equator moves southward during winter season. Next, during winter season, the thermal contrast increases and the intensity of high pressure center at the pole increases. Thermal contrast increases because polar regions, they become more cold, and because of this pressure center at the pole increases, it intensifies the formation of jet streams, its extension and its velocity. In polar region, what you will see, its intensity increases during winters because of the strong thermal contrast. If this strong thermal contrast is not there, what happens? You will see polar vortex. Now what is polar vortex? We are going to see. See, this is how you have to interlink jet streams with polar vortex. Now, polar vortex is a large persistent cyclonic circulation of very cold air around the polar region, very cold air around the polar region. Now, in the upper troposphere and stratosphere, what happens? Strongest in winter, and these cold air here, stable polar vortex. This Arctic polar vortex is a band of strong westerly winds that forms in the stratosphere about between 16 kilometers, means upper troposphere and there. Here these jet streams, polar jet stream hold these cold winds, cold polar vortex, these strong cold winds like a rubber band. Now what happens if global warming increases? Here you will see the Rossby effect, weak jet streams. If jet stream becomes weak, you will see Rossby effect more, like this. Now this cold layer is strongly means this jet stream move around this polar vortex, this cold air. Now when this jet stream weakens, because of the weakening you will see Rossby effect, more meandering. What happens? This cold wind come towards downward. So what happens? It covers. Now cold layer moves south side. Because of this you will see polar vortex or cold weather. See, polar vortex disruption sometimes due to sudden stratospheric warming. Because of sudden stratospheric warming, what happens? Here you will see these cold air moves southward. Because of this you will see polar vortex disruption, and because of this you will see very extreme cold temperatures in winter because of the polar vortex disruption. Because of the polar vortex disruption, that you have to remember. Simply, what is polar vortex means? Polar vortex, we have two vortices, northern and southern, Arctic and Antarctic, a bowl of cold air packed over the poles. Now these cold air moving in circular motion because of Coriolis force, and this bowl of cold air is now this jet stream acts like a wall holding this bowl. Now when this jet stream becomes weak, what happens? This bowl of cold air moves southward, this air moves southward. Because of this polar vortex is very cold air, you have very extreme cold air is packed above the North Pole and South Pole. Now when this cold air moves southward, you will see extreme winters in those regions. Now, types of jet streams, we have two types of jet streams, permanent and temporarily. Under permanent jet streams, we have two major types, subtropical jet streams and mid-latitude or polar front jet streams. First, subtropical westerly jet streams. They move in the upper troposphere to the north of subtropical high pressure belt in both the hemisphere. It is above 30 and 35 degrees. You can see the image here. Here you see subtropical high pressure belt. Their circulation is from west to east and more regular than polar jet stream front. It flows through most of the year and is produced by rotation of earth. Most of the year you will see, but when you take polar front jet stream, it is strong during winter because you will see thermal contrast, more thermal contrast. Next, polar front jet stream, they are formed above the convergence zone of the surface. Polar cold air mass and tropical warm air mass above the surface. See, two different air masses meeting point in upper troposphere. You will see this jet stream formation. So, here warm and from 60 degrees, here you will see at subtropical high pressure belt, you will see subtropical westerly jet stream. Here from 90 degrees and from here warm air, cold, warm. Here you will see polar front jet stream. Polar front jet stream at around 40 to 60 degrees, here around 30 to 35 degrees. Thermal gradient is steep because of the convergence of two contrasting air masses. Here pressure is more when you take subtropical westerly jet streams because of the pressure, more pressure maximum. Here strong thermal gradient, that you have to remember. Now, seasonal and temporary jet streams, they form during some seasons and after that they disappear. Tropical easterly jet stream, Tej. This is very important for our Indian climate. What is Tej? The tropical easterly jet streams develop during summer seasons. Develop during summer season over our Indian land. Because of intense heating, here what happens, here Tibetan plateau is there. Intense heating of Tibetan plateau. Here you will see low pressure on the surface and high pressure on the above in upper troposphere. Because of this temperature difference, you will see the formation of tropical easterly jet streams. It flows from east to west. This you have to remember, flows from east to west. Here in upper air circulation, for example, if India, above, upper air, I am talking about upper troposphere. On surface Tibetan plateau is having low pressure because of intense heating. Our Indian continent is having high pressure on the surface. But if you are having high pressure simply if I say India, Tibetan Plateau. Here this is surface. Now this is upper troposphere. Because of intense heating, what you will see here, low pressure, here high pressure. And if you see here low pressure, aloft, what you will see here, high pressure, and here low pressure. Yes, high pressure and low pressure, and wind moves from high pressure to low pressure, and here this wind moves from high pressure to low pressure. In upper air circulation, in upper atmosphere, you will see the formation of jet stream because of intense heating of Tibetan Plateau. Because of intense heating, you will see strong pressure gradient force, and because of this strong pressure gradient force in upper air, you will see this Tej jet stream, tropical easterly. Here what you have to remember, one thing you have to remember, these jet stream, they flow from east to west. Tibetan Plateau is on east side and they flow from Tibetan Plateau to Indian side, means east to west. Other jet streams, they flow from west to east, Tej east to west. That you have to remember, very important for your Indian climate or Indian monsoon. Next, jet streams, clear? Strong upper air circulation in upper troposphere. Those strong winds are known as jet streams. We have seen permanent jet streams, subtropical westerly jet streams, polar front jet streams, and temporary jet streams like Tej, very important for your Indian climate. Because of this jet streams, monsoon is affected. That we are going to learn in Indian climate. Next, we have seen characteristics. Those are jet streams are geostrophic winds, and though they flow in a meandering path and very fast, Rossby waves effect, and we have seen polar vortex also. After that, air mass. Air mass is a huge body of air having uniform temperature. First you have to remember uniform temperature, humidity, and lapse rate horizontally over a large area. And next, essential conditions for the formation. See, every air mass have a source region, because for example, this is a desert, warm surface, and this is glacier for example, or ice covered area, cold. Now air here, when air stops, when air is accumulated here over a long period, what happens? This air attains temperature because of conduction, and this air becomes warm, and here this air becomes cool, cold and warm. After attaining this temperature, this warm air with uniform temperature and humidity, this cold air with uniform temperature and humidity, they move, this warm air move towards cold air, and this cold air mass move towards warm air. Means source region is very important for any air mass. Essential conditions for the formation. First, extensive large uniform area like desert, homogeneous surface like ocean, desert, snow filled plains, calm and high pressure, stable air. If you see stable air, you don't see mixing, vertical mixing. If vertical mixing is there, you don't see uniform attaining temperature from that surface. Next, large residence time, means air stays and acquires surface properties. If time is less, air cannot attain that uniform temperature or those uniform properties. These regions are called source regions. We have different types of source regions. 5 major source regions. First one, warm tropical and subtropical oceans, first thing. Next, the subtropical hot deserts. Next, relatively cold high latitude oceans towards temperate regions like that. The very cold snow covered continents in high latitudes. Very cold snow covered and permanently ice covered continents in the Arctic and Antarctic. Very important. All the 5 source regions you have to remember, and after the source regions we are going to see different types of air masses. First, maritime tropical over oceans in tropical areas, continental tropic over continents in tropical areas, maritime polar over polar region, maritime over oceans in polar regions. Next, continental polar continents in polar region. Next, continental Arctica here. Now, what is maritime tropical air masses? The source region of these air masses include oceans in tropic. Maritime means, first thing what you have to remember, oceans and subtropics such as Mexican Gulf, Pacific and Atlantic oceans. Specifically these oceans in tropics. First thing, Mexican Gulf, Pacific and Atlantic oceans. These air masses are warm, humid and unstable. Warm, humid and unstable. Tropical air masses are unstable because here you will see cloud formation. Warm, humid and unstable. The weather during winter has mild temperature. Next, during summer the weather is characterized by high temperatures, high humidity. High humidity means you will see formation of cumulonimbus clouds or cumulus clouds, and you will see convectional rainfall. Next, maritime polar air mass. Source region, what you have to remember, oceans between 40 to 60 degrees latitude. Actually, continental polar air Actually, these are the continental polar air masses. They have moved from continents, cool continents in polar regions towards warmer oceans. Compared to that cooler continents, oceans are warmer. Land heats up very fast and cools very slow over warm oceans and got heated up and have collected moisture. After collecting moisture, what you will see? We will see precipitation, occasional precipitation. The source regions are cool, moist and unstable. Maritime, what you have to remember, unstable. Even maritime tropical and maritime polar also, both unstable. Maritime tropical, warm, humid. Maritime polar, cold, cool, moist. High humidity, overcast skies and occasional fog and precipitation. Class unna sir? బయట స్టూడెంట్స్ వెయిట్ చేస్తున్నారా? కాంటినెంటల్ ట్రాపికల్ ఎయిర్ మాస్. Tropical air mass over tropics. Air mass is formed over tropics. The source region is tropical and subtropical deserts. So, tropical and subtropical deserts of Sahara in Africa and of West Asia and Australia. These you have to remember. They can give source regions and they can give maritime tropical source regions in continental tropical source regions, and they can give confusing statements and confusing words. These things you have to remember. These air masses are dry, hot and stable because continental you don't see any moisture or don't see any humidity. Maritime, warm, humid. Here dry, hot and stable. If humidity is there, then only you will see rainfall, conventional rainfall or cumulus cloud formation. If cloud formation is there, strong rainfall, because of that strong precipitation, atmosphere is unstable. But here dry and hot. Dry air means stable conditions. You see they are dry throughout the year. Next, continental polar air mass. Source regions, Arctic basin, Northern North America, Eurasia and Antarctica. Source regions you have to remember. Dry cold, here continental tropical means dry hot, here dry cold and stable conditions. One thing what you have to remember, dry means stable conditions, dry air means stable conditions, you have to remember. The weather during winter is frigid, clear and stable. Next, after air masses we are going to see front. What is a front? Boundary of air masses. For example, this is cold air mass, warm air mass. This front face where the two air masses meet, that is known as front. And we see four types of fronts. One is warm front, cold front, stationary and occluded. First, cold front. What happens? Formed when cold air pushes under a warm air mass. Cold air pushes. When two different air masses meet, there you will see front formation. Now what is, we are going to see cold front, warm front, stationary and occluded. Here under cold front, cold air mass pushes warm air. Now warm air ahead. Here you will see when warm air mass moves, here you will see cloud formation. This is known as cold front. In warm front what happens? Warm air pushes cold air. Gentle upliftment. Why you will see gentle upliftment in warm fronts? Because warm air is light and cold air is denser. Now this light air gently pushes dense cold air. Warm front means when warm air mass overtakes cold air mass. Now warm air mass overtakes cold. Now here cold is there. It overtakes cold air mass and this warm air mass gently uplifts cold air mass. In cold front what happens? Cold air mass uplifts warm air fast because cold air is dense. It can easily uplift warm, and because of this strong movement what you will see? Cloud formation, cumulus cloud formation, and you will see rainfall. Here in warm front, warm air rising gently over the cold air. This produces light to moderate rainfall. Light to moderate rainfall. Next, stationary form when two air masses meet but neither advances significantly. Means here two air masses meet, they say hello, hi, and they stand there. They don't move or they don't overtake any other. Here cold air, warm air. Now here warm air is moving upwards but they are here only stationary, standing there, and they are saying hello, hi, and they are not overtaking any over each other. And here because of this warm air moving upwards, here you will see extended periods of cloud cover and steady rainfall. Stationary fronts along the Gulf Coast of flash flooding events. Now occluded fronts, when cold air overtakes a warm front, uplifting warm air completely above the surface. Now cold air mass, CAM. Here warm air mass is there. Now this cold air mass completely uplifts this warm air completely uplifts the warm air. That is known as occluded front. This interaction is associated with intense cyclonic activity and heavy precipitation. Heavy precipitation. See here, cold air into warm separates fast moving cold air which pushes up from retreating warm air. Here warm front, slower moving warm air replaces retreating cold air. And here stationary air masses are not moving. They are saying hello, hi, bye bye. And they are standing there only, stationary. With the name you have to remember. Occluded warm air is overtaken by cold air. See. Now warm air is overtaken. Now role in extreme weather events, tropical cyclones and hurricanes. Warm moist air masses like maritime tropical serve as energy sources for tropical cyclones. See, rapid revision, all these important points you have to remember. And for example, cyclone Fani and cold waves, polar air masses moving into temperate zone. Because of that you will see cold waves. Polar vortex events in North America often being harsh winter conditions. Okay, let's see few MCQs with reference to jet streams. Consider the following statements. 1. There are narrow bands of strong winds in the upper troposphere. 2. They generally flow from east to west in the mid latitudes. 3. Their position shifts seasonally. Now what is the answer? First one, true? Yes. No, they generally flow from west to east. Yes, their position shifts seasonally because based on the temperature difference. 1 and 3 is the correct answer. Answer is B, statement 1 correct. Jet streams are fast flowing. Incorrect, because they flow from west to east. They shift northward in summer and southward in winter. Next, the subtropical westerly jet stream during winter is primarily responsible for southwest monsoon onset, western disturbances in North India, tropical cyclones in Bay of Bengal, El Nino formation. El Nino formation is related to warm ocean currents and cold ocean currents, not related to jet streams. Here what you have to southwest monsoon because of Tej, tropical easterly jet streams, we are going to see onset of southwest monsoon. Western disturbances in North India are due to subtropical westerly jet streams. Because of this western disturbances, we see rainfall, winter rainfall. Winter rainfall in North India, and this winter rainfall is useful for rabi crops, causing winter rainfall in northeast. In summer it shifts north of Himalayas. Next, tropical easterly jet streams is associated with winter rainfall, retreating monsoon, southwest monsoon on polar vortex. Polar vortex is which jet stream? Polar front jet stream. Here what you have to remember, polar front jet stream, southwest monsoon, Tej. This you have to remember. Associated with Indian southwest monsoon. Next, an air mass is characterized by A. Uniform temperature only, B. Uniform humidity only, C. Uniform temperature and humidity over a large area, D. Strong pressure gradient. D. Strong pressure gradient. Now, answer is C. Uniform temperature and humidity over a large area. That large area is known as source region. Next, a front is formed when two similar air masses meet or two different air masses meet. C. Wind speed increases, or D. Pressure becomes uniform. Answer is two different air masses meet. When two different air masses meet, that there you will see front formation. Boundary between two contrasting air masses. Now, a cold front is associated with 1. Steep slope, 2. Cumulonimbus clouds. 3. Thunderstorms. Select the correct answer. They are asking about cold front. Cold front means cold air mass uplifts warm air. There you will see strong steep slope. Yes, all 1, 2 and 3. Cumulonimbus clouds. As the warm air moves, you will see condensation and cloud formation. Cumulonimbus clouds and even thunderstorms also. See, cold air undercuts warm air sharply, leads to cumulonimbus clouds and causes intense thunderstorms. With this we have finished jet streams, pressure belts, air masses, fronts, everything, all topics under climatology. We are going to discuss southwest monsoon and retreating monsoon, Indian monsoon in next class. After that regarding oceanography, ocean currents and few important themes we are going to discuss about prelims 2026.